As part of algorithm that changed the world, Quickhull Algorithm is a widely used solution to a convex hull problem. The convex hull is a set of vertex that forms the shape containing all other vertices within. It determines the convex hull is a fundamental geometric problem that has application across a range of industries. Quickhull algorithm uses a divide and conquer approach. First, the line is drawn between the points furthest to the left and right on the 2D plane. These points are part of the convex hull, and the line segments the graph into two subsets. Then lines are drawn from the 2 points on the line to the point furthest from the line. This point is also part of the convex hull. The point inside the shape formed cannot be part of the convex hull, so we can ignore them. We repeat this process until all nodes are either part of the convex hull or contained inside of them. Quickhull algorithm has complexity n squared at worst and n log n at best. The worst case occurs when all vertices are part of the convex hull. The best case is when each segmentation divides the nodes evenly, and the number of vertices of the convex is small compared to the number of vertices contained within the convex hull. Okay, now I will explain my implementation to the Quickhull algorithm. So initially, I started by implementing a class called plot, which will be a model class for any points or any plots the user inputs. So we know a plots will contain an x-axis and a y-axis, and I said that in Python you could just use a representation. So if you want to print this into the console, it will print as plot, then the x-axis and the y-axis, so we know it's a plot. Then after that, I implemented a polygon model class, which will be like all the polygon that's formed from the plots, isn't it? So it will be, and it will, so the class will contain objects of plots since it's work together with plots. And the property of a polygon is the Quickhull, which is defined here. So X is the Quickhull method. So here is the Quickhull function, or the Quickhull class, which has all the Quickhull methods that need to perform the Quickhull algorithm. So this is what's happened. So this just gets the Quickhull. So it just, as you can see here, it gets the Quickhull. That's the main function in this class, and all the other method is communicated to this method only. So as you can see, it gets the furthest, or first it checks the length. If it's less than 3, it doesn't return anything, because if it's less than 3, it just creates a polygon of that 3 plots. Then if it's not, then it just finds the extreme plants. Then it finds the furthest. Then it just does a recursive process of that kind of thing. And here is the implementation of finding the furthest. Just looking at, it's just simple mathematics, just looking at if the number or the point is bigger or not, and you just have to compare in terms of like the x-axis and the y. So the easiest way is to, when finding the area kind of thing, like from 0, 0 to point, and you know which one is the furthest kind of thing. And here is the main method that I did like a GUI implementation of it, so it's easier to like visually see what's happening rather than me printing all the results on a console, because it's just hard to see like just a 2D list of all the plots, where you could just put all the plots. So for example, if I start here, then the third one draws off that. So anything goes inside, we know the concept is like it draws the furthest point. So I could put as many as I want, nothing will happen. But as soon as I put something bigger, it goes over there, and something like that, then all of that. Thank you for listening.